है। चलो लिखो, हेडिंग लिखो, मैकेनिक्स। बोर्ड क्लियर दिख रहा? चलो बढ़िया। इफ आई आस्क यू व्हाट इज मैकेनिक्स?
Mechanics, something dealing with the
हाँ, डीलिंग विथ
metal things.
नहीं। हैव यू एवर हर्ड अबाउट द वर्ड मैकेनिक?
Mechanic, bike.
हाँ, बाइक मैकेनिक, कार मैकेनिक, मैकेनिक। ओके, दैट मीन्स व्हाट दे आर डूइंग?
Some changes factors.
They are repairing generally machines, na? Yes. Okay, mechanics is nothing but it is study of motion and forces. Two things. What is motion?
Moving object.
Moving object. If object is moving, then it to be said as motion. Forces?
Force, pressure on object.
Okay. Let us try to understand. Why the body is moving? First thing, force is been applied. Whatever the kind of force, either it is gravitational force, either it is mechanical force, either by pushing, either by pulling, whatever the case is. For example, here is an object. Okay, do this object has some mass?
Yes.
Shape?
Yes.
Size?
Yes.
Yes. Consider there is a person. He is pushing the object. Will he require some force?
No.
Without force, चला जाएगा वो?
उनको force है ना, मतलब उनको apply करते force.
The person has to apply some force to push this object, na?
Yes.
Yes. If the object is moving, obviously we will call as motion. Okay. First thing. Second thing, for example, here is one person. He tries to pull this object. Pull or push?
Pull.
Pull. ये क्या कर रहा है? Pull कर रहा है. And this person is trying to push. Obviously, this object is moving in this direction. But whenever we are talking about mechanics, before resolving or classifying mechanics in terms of different forms, mechanics deals with motion of the object either by any mean. Any mean means either by pushing, pulling, or for example, consider here is a tower. On this tower, an object is being dropped. Will this object go upward or downward?
Downward.
Why?
Gravitation.
Gravitational force. Obviously, this object will be going in the downward direction. Now, mechanics is being classified into three types. Okay. First is statics. Second is kinematics. Third is dynamic. अभी मायने समझेंगे उसके. Statics. Then what?
Kinematics.
Kinematics. Third is what? Dynamics. Okay. Whenever object is at rest, if we are studying an object, if it is at rest, then we call this as particular thing statics. If the object is in motion, for example, consider this object only. If that object is in motion, do that object has shape, size, mass? It requires some force also, no?
Yes.
Yes. Whenever we are studying about motion of object without considering size, shape and mass, and the second thing, without considering what kind of force is acting on that. Okay.
Yes.
Now, whenever we are dealing with dynamics, for example, similarly, here is an object and this object is having some mass m. Why that object is in motion? If we are studying an object is in motion and due to some force. Without force, kinematics. Cause है ना भाई force. Force की वजह से तो move हो रहा है. If there is cause, if we are considering cause, then it is called as dynamics. Object is in motion? Yes. If we are studying what is the cause behind that motion, then we call as dynamics. If we are studying an object is in motion without considering its mass, without considering its shape and size, all three things, irrespective of anything, then we call that particular study is kinematics. आया यहाँ तक? Write the heading mechanics, study of motion and forces. Study of motion and forces. Mechanics is being classified into three types. Mechanics is being classified into three types: statics, kinematics, and dynamics. First, static. The study of object when it is at rest. When it is at rest. Second, kinematics. Study of motion of object or body.
Study of
Motion of body without considering cause of motion and irrespective of size, shape and mass. The next, dynamics. Study of motion of object and its cause by considering mass. What is position? Position. कुछ भी बोलो, हिंदी में बोलो, इंग्लिश में बोलो, मराठी में बोलो, मालूम है तो बोलो.
कोई ऑब्जेक्ट जहाँ पे ठहरा है, कैसा ठहरा हुआ है, उसको पोजीशन.
Okay. Let us try to understand the meaning of position. For example, if someone asks you what is the address of your house, you will be saying or you will be using one landmark.
Yes.
Yes. Can I say that that landmark is acting as your reference point?
Yes.
Yes. For example, consider here is an object A.
Yes.
What is the position? We don't know. We cannot say. But we can say that here is the location of the object.
Yes.
Pointing. Location and position, both are different things. Na? Position means with reference point. Okay. So, generally our reference point is always the origin. Oh. This is your x-axis.
Yes.
This is your y-axis. X-axis is having I cap. Y-axis is having j cap and z-axis is having k cap.
Z-axis.
Z-axis बाहर निकलेगी, मिलेगा. Generally, we have 3 dimensions. Okay. One is your x-axis.
Yes.
One is your y-axis. Obviously, considering x-axis and y-axis becomes a plane.
Yes.
Third axis is always perpendicular to these two. ये x-axis इधर गई, ये y-axis ऊपर गई, z-axis बाहर आएगी इस तरह से. Okay. Similarly, positive x-axis, negative x-axis, positive y-axis, negative y-axis. Similarly, if z-axis is positive over here outside the board, then inside the board it will be negative. Okay. Now, if I want to write the coordinate, let this point be 3 meters away from origin on x-axis and 4 meter from y-axis. Then what will be the coordinate of that point A? 3, 4. ऐसा लिखते हैं ना 3, 4. So 3, 4 is what? Coordinate. Yes. Now if someone is asking you what is the position with respect to origin, then obviously you will be drawing a line and representing here is the point A. Okay. And this represented line is called as your position vector and it is represented by R. Okay. Position vector is represented by R. यहाँ तक आया? Okay. What if I change the origin?
Origin भी change होगा.
हाँ, origin change कर लेंगे. Reference point change कर लेंगे तो origin change हो गया हमारा. While defining position, we should not say always origin. Origin is one of our reference point. Okay. So from origin, A is here, which is represented by your position vector. And how to write this? R vector can be written as 3i cap plus 4j cap. Why plus only? Because this one is having all coordinates positive. ठीक है. अगर यही पॉइंट इधर लिखता मैं, then obviously I will be writing minus 3i cap and y-axis is positive plus of 4j cap. ठीक है. स्टार्टिंग का क्लास है, धीरे धीरे पढ़ेंगे. Now R is your position vector, 3, 4 is your coordinate, point A is the location of that body. For example, if I consider origin is changed, now the origin is here. If origin is here, then from here to here already 3 na? Plus something. From here to here it is 4 na? Plus something. That means the coordinate also changes. Coordinate for this origin changes or coordinate for this origin changes? This one changes. Now consider from here to here. Let this be your new position vector. इसको R2 दे देते हैं नाम, इसको R1 दे देते हैं. Origin 1, origin 2. For origin 1 and 2, if I want to write the coordinate in generalized form, x1, y1, coordinate for origin 1 and coordinate for origin 2 can be written as x2, y2. Position change होगी. So can I say that if you change the position, reference point, position of the point changes or position of location changes? क्या बोलूं, correct क्या है?
Of location change.
हाँ, location तो वही है point.
Position.
Position changes. Location doesn't changes. If you change the reference point, position changes, but location remains same ना.
Difference between position and location.
Position and location एक ऑब्जेक्ट है वहीं पे है, उसको तो चेंज नहीं कर रहे. लेकिन जब हम पोजीशन डिफाइन कर रहे हैं तो किसी रेफरेंस पॉइंट से डिफाइन कर रहे हैं ना.
तो रेफरेंस चेंज हो गया.
रेफरेंस चेंज हो गया, पोजीशन चेंज हो गई, बट ऑब्जेक्ट तो वही है ना. So whenever a position changes, whenever the origin changes, position of the point changes, but location remains same. Okay, how to refer the position vector? Or in general form, we can write position vector can be written as x1 I cap plus y j cap. आया? पक्का? लिख लो जो समझ में आया वो. Now let us start our topic, rest and motion. Write the next heading, rest and what is rest?
Without moving.
If a body is at if a body is not changing its position, can I say it is at rest? If a body is changing its position, then can I say motion? चलो देखते हैं. For example, consider here is a train, and this in train 2 persons are sitting. एक हैंडसम बॉय, मैं, एक वेरी ब्यूटीफुल गर्ल, दो लोग ठहरे हुए कहाँ पे?
ट्रेन।
ट्रेन। एंड दिस ट्रेन इज इन मोशन and consider this train is moving with 50 meter per second. Okay, consider here is the platform. This man sees both. As train moves, he will be saying that both are in motion. Yes. Similarly, if I ask this boy, are you in motion? He will be saying, I am at rest. मैं तो कहीं गया नहीं, इधर ही बैठा है. उसी तरह से लड़की को पूछा, क्या बोलेगी? She is also at rest. But both are saying they are at rest. Why? Because they are on a same frame ना. दोनों भी ट्रेन में है ना. This person is on another frame. Yes. So rest and motion is what? Frame dependent. A body is said to be rest. For me, maybe it is at rest. For other person, maybe that body is in motion. चांद पे जाएंगे. Consider here is a person. He is on moon. Here is your earth. अर्थ गोल फिर रही है ना? Yes. मान लो ये एक्सिस ऑफ रोटेशन अर्थ का. He is standing here. Okay. At 12 o'clock, exactly at 12 o'clock, he sees this one. The person who is standing on the moon is watching this girl. Okay. At 12:30, do she will be standing there only or she changes its position? Changes its position. मगर वो तो लड़की वहीं पे बैठी है ना. Earth is rotating. Frame reference. So rest and motion. Yes, we can say rest is nothing but if an object is not changing its position with respect to time, then it is called as rest. And if an object is changing its position with respect to time, then we can call it as motion. But rest and motion both are frame dependent. आया? लिख लो. Now let us discuss with motion. Motion is being classified into three types. First is translatory motion. Second is your rotational motion. And third is oscillatory. These are the three types of motion. Translatory motion. Let us try to understand this first. If an object, consider here is an object, and this object is moving in this straight line, linear, और उसको बोलते हैं rectilinear, towards either you can call linear motion, rectilinear motion, or you can say straight line. If an object is moving in a straight line path, then it is called as what? Translatory motion. Either this translatory motion can be in this direction, either the translatory motion can be in this direction or in this direction. But if the direction is straight, then and then only we can call that particular thing as rectilinear motion or translatory motion. Got my point? Okay. Now let us discuss about rotational motion. Consider here is a wheel, and this wheel is in motion. Consider it is on the ground and this wheel is moving like this. Is it following a circular path?
Yes.
And it is also moving in this direction. Two things happening. This object is moving in this direction as well as it is following what? Circular motion. Then we can call that as particular thing rotational motion. And the third is obviously by the word you are hearing from your 7th standard oscillation. To and fro motion. Best option pendulum. Yes. So these are the three types of motion. And now what we are going to start is translatory motion. Our first chapter, that is motion in a straight line or motion in 1D, is nothing but we are dealing with translatory motion. लिख लो जल्दी. Now write the heading motion in 1D or motion in a straight line. Consider here is an object and this is the axis, x-axis, y-axis. Consider this object is moving in this direction and consider this object is moving with 10 meter per second. Okay. If object does not changes its position, it will continue in this direction only. Is it following a straight line path?
Yes.
Yes. In which axis it is moving? X-axis. And y-axis is your fixed ना.
Yes.
अभी मान लो कि यहाँ पे 4 है तो ये ऑब्जेक्ट 4 पे ही रहेगा ना. But at this point maybe it is at 2. After some time it will be 3. It will be at 4 ना. Yes. So can I say that this object right now is moving in only single axis, but in a plane. एक ही एक्सिस चेंज हो रही है. Okay. For example, here is the object. Now this object is moving in this direction. Both x-axis and y-axis changes?
Yes.
Yes. At this point it will be having some value, at this point it will be having some value. After some time the object will reach here. It will be having some different x-axis value. This one. How many axes it is using again? 2 axes. In that example, we saw that only one axis is changing. Okay. In this one, 2 axes are changing. That means, can I say that even if the object is moving in a plane, एक plane है ना, x-axis, y-axis is called as plane ना. Even the object is moving in a plane. Is it following a straight line path? Yes. Okay. Similarly, ये बोर्ड के बाहर आ रही है z. This is your y and this is your x. Consider the object is coming like this. Straight line. How many axes it is using now? 3 axes. One is using x-axis, y-axis as well as z-axis. Still it is moving in a straight line? Yes. So to understand the meaning by seeing the axes, we cannot define that particularly. और एक बार बोलूं. For example, if an object is moving along x-axis or y-axis, but its motion is a straight line, then it is called as 1D. भाई एक ऑब्जेक्ट है यहाँ पे, ये जा रहा है इधर, स्ट्रेट लाइन जा रहा है. एक ऑब्जेक्ट इधर है, स्ट्रेट लाइन जा रहा है. ये ऑब्जेक्ट है, इधर जा रहा है, स्ट्रेट लाइन ही जा रहा है. Either it is moving in y-axis, either it is moving in x-axis, either it is moving in x-axis and y-axis, or if the object is moving like this, unless and until it is changing its direction. If an object is following straight line either in any axis, then it is a 1D. Okay. Now, for example, if I mention like this, V is equals to 2i cap, straight line.
Yes.
V is equals to 2i cap plus 3j cap, straight line. Yes. V is equals to 2i cap plus 3j cap plus of 4k cap.
Yes.
Yes. By seeing the I cap, J cap, K cap बोलना नहीं है, ये 1D है, ये 2D है, 3D है, नहीं. स्ट्रेट लाइन है 1D. आ गया? चलो अभी थोड़ा आगे जाएंगे. Okay, now, for example, object is moving like this. 1D, 2D.
1D तो होता.
1D तो नहीं है, तो 2D है। समझ रहे हैं बात को? Is it moving in a straight line? No. Then if it is not moving in a straight line and it is moving in a plane, कौन से प्लेन में? XY plane ना? If the object is moving in any direction, but it should be moving in a plane and changing its direction, 2D. इसको ऐसे भी रिप्रेजेंट करो, ये 1D 2D 2D, ये जो ऐसा जा रहा है 1D 2D 2D, ये ऐसा जा रहा है 2D. It is taking a plane. Whenever object is not moving in a straight line and it is following in a plane, then we call it as what? 2D motion. चलो, ये आपकी z axis बाहर, z axis is here, your x axis, here is your y axis. Now body is here initially, it is going in this direction, it is going in this direction, randomly moving in this direction, out of the board, फिर वापस अंदर 3D. Why 3D? It cannot be defined in a plane. Yes, na? It is taking how many axes? 3 axes. Yes, it is taking 3 axes, but it is following all 3 axes, na? It is in x-axis, it is in y-axis, and also in z-axis. So such kind of motion is nothing but 3D. By looking I cap, j cap, and k cap, we cannot say that object is 2D, 3D, or something. 1D. आया?
Yes.
पक्का? Okay. Now write the heading, distance and displacement. From here we are starting our chapter in reality. Shall I? Consider here is a body A. Right now the body is at A. And we need to go at this point B. Consider your point A is your college and point B as your home. Okay. If I am moving from point A to point B in a straight line, one option number 1, consider this as path 1. Okay. Consider path 2 is here. From point A again reach to what? Point B only. But this is path 2. Consider point A to B is 100 meter. 100 meter, path B is smaller or path 1 is smaller? Path 1 is smaller. Definitely path 2 will be having, let's say, 200 meter. Okay. Consider one more path. Yeah. Path 3. Consider this as 500 meter. Which one is your shortest path? 100 meter. Path 1 is your shortest path, na? 100 meter. Let us try to understand this. Path 1, path 2, path 3. Shortest is path 1. The longest one is 500 meter. That is path 3. In path 1, can I say that? Consider here is a girl. She is following path 1. लड़कियां सीधा कॉलेज से घर से कॉलेज ही आती है ना? Yes. थोड़ा छपरी टाइप लड़का, ये छपरी लड़का क्या करता है? घूम फिर के जाएगा. वेरी वेरी छपरी इधर से जाएगा. So all are reaching to point B. Someone is following path 1, someone is following path 2, and someone is following path 3. What is the difference between these paths? Only distances or the measurement is the difference? Okay, time. हाँ, वो बाद में देखेंगे टाइम का. स्पीड में देखेंगे क्या होता है. अभी ये बताओ, path 1 is the smallest one. Is it having a fixed direction? Yes. Path B. Random directions. Path 3 is having more random directions. So if a object is following a fixed direction, and that direction, by following that direction, it should be the smallest one. It should be the smallest, or we can say shortest. If it is following a direction, और क्या करना है? And it should be what? Shortest path. Okay, then we call this as displacement. Okay, similarly distance, if I want to define distance, can I say that it should be the actual length or the actual measurement what we are measuring in irrespective of directions? Irrespective of, ना तो डायरेक्शन है ना तो कोई किधर भी चले जा रहे. So actual path without direction or many directions. बोल सकता हूँ? Okay. So then distance is nothing but actual path
irrespective of direction.
And irrespective of directions. ये तो हो गई छोटी छोटी बातें. रैप कर दो ये. If it is having the direction, displacement is having what? Direction. Can I say that direction is a vector quantity? Yes. तो फर्स्ट पॉइंट क्या होना चाहिए? डिस्प्लेसमेंट वर्सेस डिस्टेंस में वेक्टर क्वांटिटी लिख दूं. ये वाली कौन सी होगी फिर? स्केलर क्वांटिटी. ओके, फर्स्ट पॉइंट डन. Definition done. Shortest path with a fixed direction. Displacement. Actual path irrespective of directions or many direction. Distance okay. Second thing is displacement is a vector quantity. Distance is a scalar quantity. Now let us try to understand this. Consider point A. Here is your point B. And here is your point C, 4 meter. AB is how much? 3. BC is how much?
4.
What is the distance traveled?
From
A to C?
A to C, 7.
7. Shortest distance?
From A to B.
From A to C, what will be the shortest distance?
7.
ये तो longest हो गया ना.
A to C and 7.
Can I say that A to C will be the direct path?
Yes.
Yes. Can I say that this one becomes 5 meter? कैसा?
Short होगा.
हाँ शॉर्ट हो गया, मगर वो 5 क्यों लिखा? हाँ ठीक है, बट वो 5 कहाँ से आया? ये 90 डिग्री है पाइथागोरस थ्योरम से. हाँ. So this one is what? 5. This one is your 3. This one is 4. 3 square 9. 4 square 16. Under the root of 25 becomes 5. Okay. Can I say that AC is your displacement?
Yes.
A to B, B to C is your distance. अच्छा लिख के देखें. So distance. अच्छा वो वैल्यू तो देख लो. Whenever we write like a bar, डिस्प्लेसमेंट,
बाहर जाए तो डिस्प्लेसमेंट,
डिस्प्लेसमेंट वेक्टर फॉर्म, विदाउट बार डिस्टेंस। कोई भी वैल्यू ले लो, x ले लो, इसको x ले लो, इसको x ले लो, ऊपर लगा दो, बन गया क्या? डिस्प्लेसमेंट, डिस्टेंस। कुछ लोग ऐसे डिफाइन करते हैं, कुछ भी ले लो और जस्ट राइट x हियर एज अ डिस्प्लेसमेंट, s एज डिस्टेंस, कोई भी क्वांटिटी ले लो, ओके। नाउ व्हाट इज डिस्टेंस हियर? 7 meters. डिस्प्लेसमेंट बड़ा कौन है, छोटा कौन है?
डिस्टेंस बड़ा,
डिस्टेंस बड़ा है। सो कैन आई सी दैट डिस्प्लेसमेंट इज स्मॉलर देन डिस्टेंस?
यस,
बोल सकता हूँ? यस। हियर A and this is B, 10 meter, object is going in this direction. Distance बताओ, displacement,
डिस्प्लेसमेंट
इसको छोटा कहाँ से करते हैं? वही तो वही है। So can I say that in this one, distance and displacement both are equal? बोल सकता हूँ? Okay, so displacement and distance both are equal here. Over here, difference. Yes. So displacement is always smaller than distance, or it can be equal. Barabar. Okay. So our second point, can I write that distance is always greater or equal? Equal भी हो रहा है ना? Or equal than displacement. Pakka? Okay. Let us try to understand the third point. A to B, नहीं ऐसा नहीं, ऐसा करेंगे। नंबर लाइन 0. Here is 1, 2, 3. Here is also -1, -2, -3, so on. ठीक है? An object started from origin 0. Here is the object. Consider this A. Move to 3, point B. So how much it traveled? In which direction? In that direction, na? From A to B, in that direction, how much it traveled? 3 meters. What is the distance from A to B?
3 meters,
Displacement?
3 meters,
Positive, negative?
positive,
Both are positive. Yes. Then what happened is, it started from B, reached here. Now it is moving in which direction? Left hand side. How much it traveled?
more than 3 meters,
अरे मोर देन 3 को कैलकुलेट करके बोलो। 3 3 6 हो गया ना?
6, right,
उसमें क्या सोचना है? How much it traveled in this direction?
6 meters,
If we are calling displacement as a vector, then we should write the direction also.
yes,
Is it moving in negative side?
yes,
Yes. So from A to B, what is the distance?
3 meters,
3 meter distance. A to B displacement
3 meters,
3 meter. B to C, consider this point as C. B to C, body traveled how much?
6 meters,
6 meter. So distance is 6 meter. Displacement
6 meters,
6 meter. Displacement is also 6 meter, but it should be written with negative sign.
negative side,
नेगेटिव साइड में आ रहा है, डायरेक्शन चेंज हो गई। फ्रॉम A to B 3 मीटर, सॉरी B to C लिखना चाहिए था। आया? अच्छा. If someone asks you what is the actual distance traveled from A to C,
9 meters.
distance हो गया 9 मीटर. So from A to C distance is what? 9 मीटर. Displacement बता दो.
9. Shortest path.
Shortest path. What is your initial path? A. Final path.
C.
What is the distance between A and C?
9.
हाँ,
And C.
A and C 3 हो गया ना. देखो, ये वाला यहां से स्टार्ट किया.
Open line.
वो ऊपर की लाइन नीचे की लाइन छोड़ दो, वो समझाने के लिए बनाया है. यहां से यहां तक ही तो आया ना. सो कैन आई से दिस इज योर इनिशियल पॉइंट
Yes.
एंड दिस इज योर फाइनल पोजीशन.
Yes.
व्हाट इज डिस्प्लेसमेंट?
3.
3. नेगेटिव और पॉजिटिव?
Negative.
नेगेटिव. व्हाई नेगेटिव?
Because it is moving in the negative side.
नेगेटिव साइड डायरेक्शन हुआ, देख लो. ये माइनस यहाँ पे -6 प्लस ऑफ 3 -3 आया. अच्छा, थोड़ा और जाएंगे तो यहाँ पे क्या मिला? डिस्टेंस इज ऑलवेज पॉजिटिव ना. डिस्प्लेसमेंट इज नेगेटिव हियर. बराबर. सो डिस्प्लेसमेंट इज नेगेटिव एंड डिस्टेंस पॉजिटिव. पहला वाला डिस्टेंस क्या मिला हमको? पॉजिटिव मिला. डिस्प्लेसमेंट क्या मिला? नेगेटिव मिला. ओके, नाउ सेम 0 1 2 3 मान लो कि 4. ओके, body started from 0, reached to 4. A and this is your B. How much distance traveled again?
4 meters.
Displacement?
4 meters.
4 meter. Both are equal? Yes. Body came back here to point. This is your 4 meter in this direction? 4 meter in backward direction, na? Okay. So 4 meter in backward direction. तो क्या नेगेटिव लगा दूं अब की बार? डायरेक्शन चेंज हो गया ना. देखो, A से B गया, कितना गया? 4 मीटर. वापस कहां पे आया? पहले वाला डायरेक्शन ये था. अब की बार कौन सा डायरेक्शन? उल्टा है. सो उल्टा डायरेक्शन के लिए क्या लगाना पड़ेगा? नेगेटिव लगाना पड़ेगा. तो ये 4 मीटर हो गया. इन फॉरवर्ड डायरेक्शन 4 मीटर, रिवर्स डायरेक्शन 4 मीटर. नेट डिस्प्लेसमेंट कितना? 0.
Net displacement.
देखो भाई, पॉइंट ए से स्टार्ट किया, पॉइंट बी पे गया. व्हाट इज द टोटल डिस्टेंस
4 meters.
फ्रॉम बी टू ए? अगेन
4 meters.
टोटल डिस्टेंस 4 मीटर प्लस 4 मीटर 8 मीटर. तो डिस्प्लेसमेंट हो गया, सॉरी डिस्टेंस हो गया हमारा 8 मीटर. ऑब्जेक्ट केम बैक टू पॉइंट, सेम पॉइंट ना. 4 मीटर इन फॉरवर्ड डायरेक्शन पॉजिटिव 4, 4 मीटर इन रिवर्स डायरेक्शन नेगेटिव 4, पॉजिटिव 4 प्लस नेगेटिव 4 0.
Minus करे 0 में.
हाँ, वही तो बता रहा हूँ ना. और इन सिंपल वे, व्हाट इज योर इनिशियल पोजीशन?
0.
0.
Yes.
फाइनल पोजीशन
0.
व्हाट इज द डिस्प्लेसमेंट?
1.
जहां से गया था वहीं पे आ गया.
Yes.
तो कहाँ गया वो?
वही है.
वहीं आ गया, गया ही नहीं कुछ. तो डिस्प्लेसमेंट क्या हो गया? 0 हो गया. डिस्टेंस कितना हो गया?
4.
8.
तो वापस जाके उस
कहीं पे भी जाओ, यहाँ से बी तक गया तो वापस तो ए पे आया ना. तो डिस्टेंस इसके स्केलर क्वांटिटी है ना. डिस्टेंस इज अ स्केलर क्वांटिटी. सो बॉडी ट्रेवल्ड फ्रॉम ए टू बी, देन बैक फ्रॉम बी टू ए. टोटल डिस्टेंस ट्रेवल्ड 8 मीटर एंड डिस्प्लेसमेंट इज नथिंग बट 0. सो सेकेंड पॉइंट में क्या मिला हमको?
Distance is 4. 8 meters.
डिस्टेंस पॉजिटिव ही मिला ना 8.
Yes.
डिस्टेंस तो 8 पॉजिटिव मिला. डिस्प्लेसमेंट क्या मिला?
0.
0 मिला. फर्स्ट वाला ऑप्शन किधर लिखे, यहाँ लिखे, डिस्टेंस इज पॉजिटिव, डिस्प्लेसमेंट इज नेगेटिव. सेकेंड वाले में क्या मिला, डिस्टेंस इज पॉजिटिव, डिस्प्लेसमेंट इज 0. लेट अस ट्राई टू अंडरस्टैंड द थर्ड थिंग. Point A, body started, reached to point B. Consider this is 4 meter. Body, what is the distance between A and B?
4 meters.
Displacement?
4 meters.
उधर ही रुक गया.
Yes.
Body stopped at B only. What is the distance? 4 meter. Displacement 4 meter. Both are positive, negative?
Positive.
Both are positive. So third case क्या मिलेगा हमको? Distance positive. Displacement is also positive. So can I say that distance is always positive?
Yes.
Distance is always positive. Displacement can be positive, negative, or it can be 0. So our third point should be distance
Distance is always
always positive. Displacement
positive.
can be positive, can be negative, or 0. आया, छाप लो. What is the SI unit?
System International.
हाँ, System of International. SI unit of distance. मीटर. डिस्प्लेसमेंट, हाँ, मीटर पर सेकंड वेलोसिटी हो जाएगा या स्पीड हो जाएगा, मीटर.
Displacement also meter.
Yes. So distance and displacement both are having SI unit of meter. Next. Dimensional formula. मास है मीटर में, डिस्टेंस में,
Distance mass.
टाइम है,
Yes.
कहाँ है, ये तो मीटर ही है ना, तो मास है. देयर इज नो मास, देयर इज नो टाइम, सो मास इज 0, टाइम इज ऑल्सो 0, ओनली लेंथ इज देयर ना. मीटर इज नथिंग बट मेजरिंग द यूनिट ऑफ लेंथ ना. सो कैन आई से दैट डायमेंशन फॉर्मूला, ये पता है ना डायमेंशन फॉर्मूला. हाँ, इसको कैसे लिखते हैं, m⁻⁴ l⁻⁴ t⁻⁻, 0. Dimensional formula for both distance and displacement. m⁻⁴ l⁻⁴ t⁻⁴. SI unit always meters. अच्छा, can distance be 0?
No.
सोच के बोलो, think and tell me. We are saying that displacement is either positive, negative, or 0. What I am asking is, can distance be 0? Pakka. When? If a body is in motion, ध्यान से सुनो, if a body is in motion, distance can never be 0.
Yes.
Can never be negative.
Yes.
Distance ना तो negative मिला हमको, ना तो 0 मिला. But when?
When it is in motion.
Motion. Distance can be 0. Yes, it can be 0. But if the body is at rest.
वो रेस्ट पे तो डिस्टेंस कैसे ट्रैवल.
क्वेश्चन आया था ना, कैन डिस्टेंस बी 0? ऑप्शन दिया 4. बॉडी इज इन मोशन, हाईली इम्पॉसिबल. बॉडी एट रेस्ट, यस. यस, पॉसिबल क्या? यस. कैन डिस्टेंस बी 0? यस. दिस कैन बी 0 if body is at rest. हो गया, ये दोनों भी हो गया. सारी चीजें रब कर दूं. सुनो, consider here is a point A, and this point A is having the coordinate x1 comma y1. Okay, and here is the point B, and this one is having a coordinate x2 comma y2. Then this can be denoted by delta r. Delta r is nothing but displacement. Okay, and then what is our frame of reference? Always reference point क्या है हमारा? Origin है ना reference point. So from here to here, this is your r1 position vector, and from here to here r2. So r1 vector and r2 vector, that provides you delta r, and delta r is nothing but displacement. How to write this one? Delta r is nothing but r2 vector minus of r1 vector. उड़ गए तोते. ये क्या पॉइंट रिफर करता था? लास्ट टाइम थोड़ी देर पहले पढ़े ना हम लोग पोजीशन वेक्टर में. If here is a point A and this one is having a coordinate x1 comma y1, from this point to this point is your position, na? Yes. That means object started from here. Right now, what is the location of point A? Here. With position vector r1. This is your origin. Object किधर भी गया होगा. Consider this point A started from here, went यहाँ आके रुक गया. This is your distance ना. Point A to point B, yellow line, this is your distance. But this is your point B. Let this be x2 comma y2. Shortest distance between A and B is your displacement, na? Yes. What is the position vector for B? We have to represent from again origin, na? Yes. So this is your R2 vector. R2 minus of R1. This line. This is your delta R. समझ में आया? कोई नई चीज नहीं पढ़ रही, पोजीशन पे ही पढ़ रहे. So R2 minus of R1 is nothing but delta R, and delta R is your position, displacement vector. How to write this? What is the coordinates of R2?
x2.
लिखते कैसा बताया था? x2 I cap plus y2 j cap. बताया था ना अभी? Minus of x1 I cap plus y1 j cap. Solve करो. This becomes x2 I cap minus x1 I cap. ये plus y2 j cap minus of y1 j cap. If I take the common, x2 minus of x1 I cap plus of y2 minus of y1 j cap. ये क्या बन गया आपका? डेल्टा आर. Either represent like this, either represent like this. Meaning is same. Okay. The next thing, if someone asks you what is displacement vector, displacement vector is different. Vectors पढ़े ना? पक्का. यूनिट क्या है? स्केलर्स एंड वेक्टर चैप्टर का नाम है ना? नहीं पढ़ा है वेक्टर्स? छोड़ो, ये तो समझ में आया ना? हाँ बस. नेक्स्ट थिंग, इफ आई वांट टू कैलकुलेट द मैग्नीट्यूड, जनरली वी आर सेइंग अगेन एंड अगेन डिस्प्लेसमेंट डिस्प्लेसमेंट डिस्प्लेसमेंट. इफ आई वांट टू रिप्रेजेंट इन टर्म्स ऑफ पोजीशंस, देन डेल्टा आर, दैट इज मैग्नीट्यूड ऑफ डेल्टा आर, मॉड लगाते ना? ये भी नहीं पढ़ा है. ये दो बड़े डंडे दिख रहे ना? Whenever we write like this, that means we are talking about only magnitude. Magnitude means, for example, displacement. Displacement is a scalar quantity or a vector quantity? Displacement, vector quantity. Vector quantity means what? It should be having magnitude as well as the direction. ये magnitude हो गया, एंड क्या हो गया उसका, डायरेक्शन हो गया. फॉर एग्जाम्पल 3 मीटर टूवर्ड्स नॉर्थ, क्या मतलब इसका, व्हाट इज द मीनिंग ऑफ दिस वन? 3 मीटर टूवर्ड डिस्टेंस नॉर्थ ना, नॉर्थ इज द डायरेक्शन, 3 meter is the magnitude. Got my point? If I want to say only magnitude, that means I don't want to consider direction. समझ आई? तो जब भी मैं ऐसे मॉड लिखूं, that means I am only talking about this magnitude. I am not talking about the direction. पक्का? इसी को ऐसे लिखते हैं. आया? Then we write under the root of x2 minus of x1 का square plus y2 minus of y1 का square. What is this? Magnitude of displacement. Displacement. लिखो, रब करके दूसरा लिखेंगे. While representing magnitude, we don't require I cap j caps. इसको लिखने की जरूरत नहीं है. Okay. Whenever we are talking unit vector या फिर डिस्प्लेसमेंट वेक्टर, उसको डिफाइन कैसे करते हैं? यूनिट वेक्टर मीन्स आर कैप. व्हेनेवर वी राइट कैप लाइक दिस, आर कैप, यूनिट वेक्टर इज नथिंग बट डेल्टा आर अपॉन डेल्टा आर. अब क्या करूं? डायरेक्शन अपॉन मैग्नीट्यूड. Unit vector is provides the direction and having the magnitude 1. इसको अगर simplify में देखेंगे आप, delta r is nothing but magnitude of delta r into unit vector. In reality, to understand this in this form, this tells you magnitude. This tells you what? Direction. What is this? Displacement. So displacement is nothing but magnitude as well as its direction. Who provides you the direction? Unit vector. Who provides the magnitude? This one, delta r. Mod of delta r. Mod means only magnitude. Okay. Now, displacement vector. डिस्प्लेसमेंट वेक्टर. अब अगर डिस्प्लेसमेंट वेक्टर की बात करें तो यहां पे लगाना है हमको डेल्टा आर. ओके, सो डेल्टा आर इज नथिंग बट डायरेक्शन ऑफ आर, मैग्नीट्यूड. डेल्टा आर कितना है अभी लिखे ना वहां पे, x2 माइनस, सो डेल्टा आर इज नथिंग बट x2 माइनस ऑफ x1 आई कैप प्लस y2 माइनस ऑफ y1 j cap upon magnitude of delta r under the root of x2 minus of x1 whole square plus y2 minus of y1 whole square. ये हो गया आपका डिस्प्लेसमेंट वेक्टर. फॉर्मूला. रटो मत, अभी समझा है ना एक चीज. डेल्टा आर, ये याद रख लो, डेल्टा आर इज नथिंग बट, बोलते जाओ, मॉड ऑफ डेल्टा आर इंटू